Hi, my name is Julian Nadeau. I'm a production engineer at Shopify. You might have seen my colleague Edward in the last presentation. He and I work on the same team. You can find me here, the same username on both GitHub and Twitter. And I'm going to be talking about avoiding cognitive overload using tests, error messages, and other techniques to increase productivity and educate developers in your organization. So a bit of a background first. There we go. So Shopify is a multinational commerce company with over 600,000 merchants. We have one of the largest Ruby applications in the world with over 12 years of commits from thousands of developers. And Shopify started in Canada. So in Ottawa, Canada, our co-founders wanted to sell snowboards, but found that no commerce software really provided that online experience, so they built the software. But found out that people wanted to buy the software more than they wanted to buy their snowboards. So they started selling the software. And so they chose this newfangled technology at the time called Ruby on Rails and became one of the first Rails applications in the world. I think we started on Rails 0.18 and now run on 5.2. And now we have offices across the world, including one here in Japan, in Tokyo. And so within Shopify, I work on a specific team called Developer Productivity. And so my job is to make sure developers are fast, make sure they can work efficiently, make sure they know what's going on, and to just get everything out of their way so they can focus on developing. And one of the things that I've found is that bad patterns and bad error messages can really impact the experience for developers. And so I decided to talk about this because I think it's a very important topic. And so I'm going to start by talking about mistakes. You know, everyone makes mistakes. You do, I do. Doesn't matter who you are, what level of developer you are, you're going to make a mistake. I'm going to talk about the impact that those mistakes have on developers, specifically about cognitive overload. I'm going to talk about issues and problems, so what I call documented mistakes. What happens if you want to ban specific gems in your organization or specific patterns, you know, non-idiomatic things. And I'm going to talk about a concept we have at Shopify called shit lists. I'm going to talk a little bit about solutions and how unit tests aren't just for business logic. I'm going to talk about style guides. I'm going to talk about a topic that's dear to my heart called just-in-time education and messaging. I'm going to talk about how you can write error messages that don't completely suck. And I'm going to talk a little bit about some other techniques and bundler plugins. And I want to start this presentation by saying that I assume your organization has a culture where continuous integration is essentially God on a pull request, and you can't merge without the test passing. If this isn't true, you're not going to get as much benefit from this talk, but you'll still get some. And so, mistakes. A user makes a mistake. They miss a require statement. You know, this might seem like something that is obvious, but if you've ever worked with autoload paths in Rails, you'll know that require statements can sometimes not be required and sometimes be required, and it's kind of a mess, and it might not pop up in every case. And so this makes it into production. A user makes mistakes. They add a gem to the code base where you already have a similar one. Let's say they add the Faraday gem, which is a network gem, but you already have HTTP party. You know, you don't want two different things doing the same thing, so that's a mistake. A user makes a mistake. They forget to include a helper, but their code seems to work fine, but now there's a different API, and you can't look and introspect into that class as well. These are all different kinds of mistakes that can be made, but I don't want to focus on mistakes. I want to focus on the impact that they have. The impact that these things can have on developers aren't always just that they interrupt and cause errors. You know, that is obviously an impact, but how you react to them can also be impactful to developers. If you talk to your developers and you say, hey, look, you can add this gem, but you can't add this gem, and you can't do this, and you can't do that, it becomes a little bit overloading. And so before we go any further, I've mentioned cognitive overload a few times. I want to define that so that everyone's on the same page. So cognitive overload is defined as being given too much information all at once, resulting in the incapability of processing that information or remembering it all, kind of like these presentations today. And so I have a few more examples I want to kind of go over that, and these are real examples that happen at Shopify. Of course, not with this name, but don't add this gem. Don't add gem food. You know, if you add this gem, then it's going to cause some issues because we already have a similar gem or it has security issues, so don't add that gem. You need to make sure that you put a space after or before the curly braces so that everything stays consistent and everyone can read things fast. That's just an arbitrary decision we made in the company, but you also need to make sure you include helper in all the files so that we have proper APIs, proper tests, proper, you know, all that fun stuff, and you need to make sure that you document your public interfaces, but don't document your private interfaces. And you need to make sure that the files in your follow this convention that we've somewhat arbitrarily decided because that's just what we do, we make decisions, and they help everyone read things better. You need to make sure, and you kind of get what I mean, like these are thousands and thousands of things, especially in larger organizations. And what you might not know is that people make 40,000 odd decisions a day, and if we even make a mistake on 1% of those, you know, that's what, like 400 wrong decisions every single day from every person times the number of people in your company. You're going to have a lot of mistakes, so we need to make sure that we can tell people about these mistakes, avoid those mistakes, without telling them this long list of, you know, kind of bullshit of just like, this is a bunch of stuff that we want you to remember. Make sure you remember it. And so that got old really fast. I kind of spoke fast to illustrate why it sucks. And the thing is that people aren't going to remember this. And you know, the question that I started to have over the past few years is we make software to automate tedious crap away. Like, we don't want to let our users do all this tedious stuff. Why are we letting our developers do that tedious stuff as well? So can we automate that pain away? We probably can, but I want to ask what happens if we don't. So if we don't, developers have to remember this list of thousands of things that they remember for all those 40,000 decisions they make every day. This, of course, takes attention away from the thing that, you know, they were hired for, you know, building software and architecting great code. And humans are error-prone. They make mistakes all the time. I mean, you'll probably find a few mistakes in this presentation alone. Communication is also really hard. You can email everybody and hope that people, you know, search it and read it, but somebody's not going to hear it and somebody's not going to see that memo. We have, you know, over 1,000 developers. I don't actually know the number right now, but with over 4,000 people in Shopify, over every time zone in the world, you can be assured that everyone doesn't read every single thing that gets sent out. It's just too much. And now that people have made those mistakes, your application is broken because somebody forgot to include a require statement or something. So, cognitive overload and mistakes. When an logic error is found in the code base, many people will reach for a unit test. You know, if I input this number or this string or this object, I get this other object that's expected back out. But when it's a project or infrastructure mistake, I found that a lot of times people reach for guidelines or best practice mantras or talks like this one, or documentation on contribution guidelines, which are fantastic, at least you're documenting it, but people aren't going to read them. There's too much stuff to read. So they get cognitively overloaded. But can we make these things testable? So, fixing the problems. You know, we just talked about all these different things. Like, what are the base steps? You know, step one is obviously to identify the problem. You need to know what you're solving. Step two is to determine if it can be automated. Can you detect certain output? Like, I run this command, can I find output from that and make sure it's there? Can you read the gem file, or gemfile.lock, and parse it using Bundler's API and see what was included? Can you parse or lint the code? Can you run the program, like literally just run the program and check some state afterwards, etc. And finally, you implement a test to detect and educate developers. And so the rest of the talk will focus on examples and explaining these steps a little bit more in detail. So to kind of overview what we just read, people make mistakes, they're going to happen. Telling people what mistakes to avoid just creates a cognitive overload, and those mistakes will happen again. But we can identify, automate, test, and educate instead. And this will help be more productive in general. And so issues and problems. I'm going to start this with what I like to call documented mistakes. These are some real-world examples from within the Shopify organization. And so one of the examples that I have is broken maintenance tasks. In our core application, we have a concept called a maintenance task, which is to fix data that's been broken. And we have tests for those maintenance tasks. We assume that a task named mytask.rb will have an associated file at the same subdirectory structure under the test folder called mytasktest.rb. But sometimes users do not name them correctly, whether they refactor and rename and forgot to rename the others, and this breaks our tooling. And so I know this is probably hard to read at the back. The content of the test is not important. You can read that later, but I'm going to highlight a few parts here to kind of illustrate ways you can write these tests yourselves. And so the first line actually goes through and just does a glob across all directories to find all files that end in task.rb. The second line does the same thing, but finds things that ends in task_test.rb. We go through every single one of those tasks, and we make sure that if we remove _test, there's an associated task for that test. And this makes sure that they match. If they don't match, we send a nice little error message down here saying, hey, something's wrong. You can't pass, it doesn't pass yet. And now the code works fine. The code is perfect, except that it's not named properly. So the code is actually not perfect because the structure and formatting of the code is just as important as everything else. And so we don't just tell the user, hey, this is wrong. We also explain why it's incorrect and suggest resolution steps. And those last two are very important. And this is what it'll look like in a proper failure. You explain what the problem is. Maintenance task tests file names need to match that of the actual task. And so test maintenance my super task test is for my super task. However, in this part, we tell them what didn't match. And you might notice right away that the name is remove orphan nav items with 2 S's, task. And what you'll be able to point out from here is that I have 2 S's here by mistake. And that might not be caught because it's not called out to them. And so this also specifically calls out, make sure you check for spelling mistakes, like that double S. And what this means is that we can no longer push that broken code into production. Another example is in one of our command line applications. We optimize for a quick boot time, and so that means we want to make sure that the load path on boot is as small as possible. And this is because we want things to be near instantaneous. So we need to make sure that we don't increase that load path by mistake. So here's the entry point. You'll notice a few things that we do to make sure that the load path is small. And one of them is we disable gems, which means that we don't have any of the bundler load path in the application. We include specific libraries, and we require the application. And then this part at the bottom here, if we give an environment variable, print loaded features, we're actually going to just print the Ruby constant loaded features, which includes everything currently required and in your load path. And this allows us to now test this application. And so at the top here, we literally craft a command, which is Ruby disable gems with this library, run the file that I just showed you in the last one. And because we pass this print loaded features, the output of this command will just be the things that are required after we boot the application. So we can take those required files, we then compare it against a hard-coded array of expected files that we want, and then make sure that the expected files are loaded so that the array doesn't become outdated, and make sure that all required files are expected so that we don't accidentally add things to the load path. And so this might seem really simple and basic, but before when we were writing this application, we had issues where every time you wanted to add a require, like require YAML or require JSON or something, we were afraid to put it at the top of the file because we didn't want to increase the load path by mistake. And while this worked with 2 people working on the project, we started hiring more people and we started getting contributions from outside of our team, And we constantly had to explain this time after time again. And it really sucks if I have to take my time to go and explain something to somebody else, meaning I wasted my time and their time when I could have a test that tells this to them without my interference. And also, like, I actually have to sit there and think, will this increase the load path? You know, that's something a computer can do, so let's make a computer do it. And so those are just two examples that you can use. I'm going to have a few more later, but I wanted to illustrate just some stuff up front. And so what happens if you want to ban specific gems or patterns? Well, sometimes in an organization, certain gems or patterns are not idiomatic, or you want to upgrade a gem, like Edward was talking about in the last talk. You might want to consolidate on certain patterns or change patterns and APIs. And you want to be able to accomplish all of this without telling people, don't do this and don't do that. Just to avoid that cognitive overload. And so we use a concept called shit lists. This is mentioned a lot in our core code base, with over 181 mentions of it in just the Shopify core application. And so what a shit list is a technique to list a bunch of things that is deprecated or we consider a bad pattern, and we write a test that ignores those instances. And so, like the technique or the test I just showed you, we can write a test that makes sure nothing is unexpected, but when you already have hundreds or thousands of these failing tests, for example, or bad patterns, you can't migrate it all at once. And as you're trying to fix those, you don't want people to add more work and keep increasing your workload. And so you write a test that will fail on new violations, but not on old ones. And the goal is to migrate those old ones over time. And so an example here is we're actually translating our core application into Japanese. But we can't do it all at once, and we don't want people to add more English-only content. So what we did is we made a list of all things in the application that are English-only. And then we fail if that list changes, aka somebody adds something or somebody removes something. This makes sure that the list stays up to date and nobody adds new English-only content. So this means we're allowed to change old stuff, but we don't add more work to the migration. And so an example in a more infrastructure perspective is Git gems. Almost a year ago, I looked at Git gems and realized they were really non-performant and caused a lot of support issues. We decided they were a bad pattern because of network performance and SSH configurations causing problems in developer laptops and in CI. And so what we decided to do was ban them. And we did this using the bundler API. So, like before, we first determine everything that we have. So I figured out all the dependencies we have by parsing the gem file. And we select all the ones that has a source of Git. We then figure out which ones are expected. We already had like 150 gems that were based on Git, and so we wanted to avoid adding more. So we created a Git gems shit list and then read that into an array. And then we go over each individual source and make sure that it is expected. And if it is not expected, we tell people, hey, you added a new Git-based gem, this is deprecated. The reason this is deprecated is because it causes performance issues and just causes support debt. There's more information at this project, so go to this link to see that information. But to continue forward, you need to change this to use a non-Git source. You can use packages.shopify.io, which is our private gem host, to host private gems. We're writing documentation to help this process. And so what this now means is that people can do their work, and they only find out at the time of trying to add a Git gem that they're actually not supposed to do that, and they don't have to remember it. We don't get more work in that migration, and this has actually been very helpful. Another aspect, or another perspective that we use, or example, is that there's certain gems that we decided aren't to be used in our core code base. Whether they have security issues, performance issues, we don't think they're written well, or we already have an alternative for them. A good example here is RSpec. As you might have heard in Edward's talk, we use Minitest. RSpec does the same thing, essentially, and so we don't want to have two different test suites when we already have tooling around Minitest. So instead of telling everybody, especially new people, don't add RSpec, we write a test that will fail if they try to add RSpec, and then tell them, why. I'm going to touch on this a little bit in a few slides again, but I just wanted to give that example here. And so the overview for this section is that we can document mistakes using tests. We can enforce specific idioms like patterns, API usage, and gem usage using tests. And we can use strit lists to migrate non-idiomatic ways and migrate to a better way. And so let's talk a little bit about solutions and education around this topic. So unit tests. This is a unit test. It tests some logic in your code and assumes that given an input, you get an expected output. And you get something really basic. Given the integer 9 to the method square root, we expect 3, and the square root of 2 should be 1.4142. And this has a really simple input. It has the input of an integer, and we get an output of some numeric value. But what if the input was all of your code? So this is a test that takes your entire code base and just shoves it into the test. What can we do there? Well, given a project or the code base, we can say, we expect that a set of files will be loaded after launch, like the example I showed you. Or all gems are sourced from Ruby gems, similar to the example I showed you before. Or malicious gem is not present in any of our dependencies. Or a gem we decided to use an alternative for, say Faraday over HTTP party, is not present in our dependencies. And you can think of probably a few more examples by parsing and linting code. And so unit tests can actually be used to test the code itself without even running it. And so this is another example. Within one of our code bases, we wanted a central docs location so we could track usage. So instead of directly embedding them in error messages, we have a central location that tracks usage. And so what we do is we literally go over all the Ruby files in the entire project and say, if any of these literally include the substring development.shopify.io or stack.shopify.io, fail this test. And we fail it because it references a doc. Please use this alternative solution so we can track usage. And this tells you why it failed, what failed, and gave you a resolution step all in one sentence. And this is really simple. I mean, it just reads a file in with a file.read and just says, refute includes this substring. It's nothing complicated, and so you can do this fairly simply. Another example is make sure migrations reference valid tasks. We had issues where a migration would run a maintenance task, and somebody would reference maintenance task foo, but then another person, while this one change is up as a pull request, would remove foo task, and then everything would just break. And so we just go through and tell people, hey, you referenced something that's invalid. And this has helped us avoid a lot of breakage within our code bases. Back to the example before about get gems. We wanted to make sure that certain gems were removed for a reason aren't added back. For example, we don't want people to add rspec because we all use Minitest. And so we have this entire blob at the top that just says stuff like, hey, we want you to understand what you're doing. Like, I know rspec doesn't seem bad. It's not a bad gem, but we don't need to use it because we already have one, or we don't use a lot of the code, or it provides wrong functionality, or maybe it's not supported upstream anymore. We need to make sure that you know what you're doing, and then we actually give a specific error message per gem. And so that's what this entire thing does, is we just make sure that anything that we declare as removed is not present in any of our bundler definitions. And so this allows us to take time to educate people about why they shouldn't add specific gems without going and saying to 1,000 to 4,000 people, don't add rspec, don't add this gem with a security issue, or don't add this other gem that we only use like 3% of. This increases our load time, it increases our boot time, it increases upgrade times when we upgrade Rails or something. It allows us to educate people the moment they try to add the gem versus telling them in advance. And so you can test the project, and it can be complex. You can go as far as using Ruby's Ripper API, which will split apart the code into a sexed parser, and then parse down the actual parse tree to figure out certain things or certain ways. Or you could use Bundler's API, like I was showing you, to check dependencies are as expected. But it can be as simple and less complex as reading a file into a string and asserting or refuting the inclusion of a substring like required test helper. And so that was actually an issue, is that some of our files wouldn't include our test helper, which meant that we weren't getting proper tracking, they weren't getting proper reporting. And so we wrote a test that tested everything in tests, including itself. So we wrote a meta test to test that our tests were testing properly. And it's literally just asking, like, does everything include a substring? And so I wanted to really illustrate that you can do some really cool stuff by just asserting the inclusion or doing some more complex stuff, but you're able to make those decisions with your infrastructure and test those best practices instead of just documenting them. Another good example is style guides. And we've probably heard about this a few times during this conference, Rubocop. Rubocop is a static code analyzer, and it defaults to using the community Ruby style guide. It analyzes the code without running it, meaning it's pretty fast. And it looks for stylistic mistakes, security mistakes, mistaken code use, and other examples. And it's a pretty good application. You can even customize it to your organization like we have. If you go through our Ruby style guide, which is open source, and go through a pull request, you'll see the average comment amount is 3,000 comments discussing whether we should use a space or 2 spaces. The normal programming idiomatic conventions. I think at one point somebody was trolling and said we should use tabs over spaces, and obviously spaces are better. But there's no right decision, despite what I just said. It is a decision, and it helps keep your code consistent. But what's important is that it's a form of documentation and education. It means that nobody needs to be told to write code in a certain way if a robot can tell you and correct it for you. And so when users make mistakes, according to your guide, Rubocop will explain the correct usage, like, hey, we don't want you to add a space here, and people will know not to add a space there. And you don't have to go and tell them, which means your pull request review can focus on the architecture, not the style guide. And this is really beneficial, particularly for more junior developers, or new people that are new to your organization, because they might not know you for some reason use tabs because you're insane. But there are problems. The errors aren't always that great. They just say, like, hey, don't do this. And as I just said, I'm not a fan of that kind of error. But also, users should be able to override with a judgment call, and you can disable that, those specific rules. And so this kind of moves into a topic that I've been touching on throughout this talk of just-in-time education. This is probably one of my favorite topics outside of actual technical stuff, because it talks a little bit about content and helping people. So what does just-in-time or JIT education mean? Well, you may have heard this a few times in context of a compiler, where it means we want to compile a code right when we need it, not before, not too late. We did right exactly when we need it. We need that code compiled. And so the concept is very similar here. This means to provide education or information at the exact moment the user needs it and not before. This means that we reduce cognitive overload because they get the information when they make the mistake instead of before they make the mistake or after they make the mistake. Like, oh, you just merged something, it broke production, shame on you, you made a mistake. You get to tell them right at the moment. And so I made a handy chart about when you should use JIT education, and you should always ask yourself, should I tell everybody to remember something? If not, then don't tell people, because they don't need to remember it. They only have to make enough decisions. If they do, you need to ask yourself, do they need to know it all the time? And if they do need to know it all the time, remember that they won't remember it because there's too much to remember. I know that's a lot of remembering, but if they do need to know it all the time, or they don't need to know it all the time, they'll never remember it because they don't use it all the time. And in the end, I always recommend just to write a test to detect and educate instead of telling people to remember or not remember and make the right decision 40,000 times a day. And so I think this is a pretty helpful chart. It has a lot of options to go through, and yeah, TLDR, just write tests. And so what are the components? Like we were talking about before, you need to detect when a user needs to know something. This might sound easy, but it's actually really hard sometimes. When does a user need to know not to use a certain pattern, or not to use a certain gem, or not to use a certain SQL query? We have a lot of problems in scaling our application with, hey, you are using a really complex SQL query that's going to query 15 million rows, and time out the database and do that over 600,000 merchants, and you now have an outage and people can't sell things. So you need to detect something properly, and it can be pretty difficult. But when you do detect it, you need to tell them, what is the problem? You can't just say, hey, there's a problem. You need to tell them what it is. You need to tell them why it's a problem, and what are the implications of making that mistake. And you need to tell them how they can fix it if possible. Getting just, hey, this is a problem, is not helpful. And what's awesome about this is everyone is happy because the developer gets to work and do their thing, and you don't have to go and tell them afterwards and then spend 3 days fixing their mistake. And so I have a scenario here. Your project expects a one-to-one mapping from files to tests, so you can run tests quick in development, and in CI, do smoke tests really quick using a scoped test suite. And the user is adding foo.rb, and they have the test foo's_test.rb. Oh no, your project expects foodtest.rb, not foo's test. So tell them what is exactly the problem. And here's a bad example. We expected file foo.rb to have a test. And this is bad because the user is going to go, I did add a test, it's at this file. So instead you can say, we expected this file to have an associated test at this location. And so we couldn't find one, which means the user might say, oh, I added the wrong test name. And it makes it very obvious instead of just saying, hey, there's a problem, or we expect you to do something, because they might have done it just not in the way you expected. Tell them what you expected exactly. Tell them why it is a problem. Instead of saying, please fix this, which they'll respond with, this is so annoying, I have so many random things I have to do, like why are there such arbitrary decisions made? You can say, if you don't put the file in the expected spot, it can impact how fast we run tests in CI and for other developers. See this pull request or doc or something for more information, which means that they can dig down deeper and they get the gist of the information that they need. And the user, unless they're a jerk, will say, well, I don't want to affect my coworkers, and I'll fix it. You need to tell them how you can fix it. Instead of just telling them nothing, which they'll respond with, oh no, what do I do now? Which happens all the time. Tell them what they should do. Give them it doesn't have to be the exact solution. You can give them a suggestion, like, please make a file at foodtest.rb. Because they might get to this point and they say, I have a file at foodtest. Oh, wait a minute, I have a typo in my name. And by calling out it explicitly, this means that they're given that resolution step, and it helps them a lot. So those are some great examples, and I want to go over a few other solutions quickly. And so you can parse output and commands and tasks. So both Homebrew and Bundler can give really nasty errors, like with GCC of just like, oh, I can't find this thing, and then you go in Stack Overflow for 6 hours and then cry because you can't figure out how to read C code. It's really confusing, and when you have thousands of developers, this is a big problem. So you can parse that output and give more context. I actually did that with this project called Extended Bundler Errors, which is a Bundler plugin. I'm currently discussing adding it into the Bundler organization, potentially, or just including it more by default. It's still a work in progress, but it's pretty promising. Here's an example. And so you have this big, long error thing of like, oh, I can't find magic config. Is that a problem? But presence of magic one day PI, no, I don't know if that's a problem. And you're reading through this and you can't figure out the real issue because there's a bunch of no's and yeses for some reason. And then the actual error, by the way, is this line here. And we can actually match on that. And instead of getting this, we can give you this. Big, bold, underlined thing. We could not install this gem. Bold, what is the problem? The issue is likely that the version of ImageMagick on your computer is incompatible, which is a lot more understandable than can't find magic1.h in the middle of a bunch of weird words. Compatible versions is this. Bold, what can I do? Here are steps that may help. Install a compatible ImageMagick, upgrade RMagick, use a different gem, and here are the original logs. And so by highlighting these in education principles, you can call it out very well. And this is actually going to be hopefully available publicly for everybody to use. And so bundler plugins are a great example of how to extend things to contextualize error handling and other things. So you can, with bundler plugins, you can add bundler commands like bundle console, can hook into various points in the install process, and can add new sources to install gems from, like Mercurial or SVN or something. You can use it to provide new information to users. So like maybe you ban gems in an organization. Instead of actually letting them install that gem, you can say like, hey, we actually don't want you to do this. or preempt installation with third versions so you can make things faster and more productive for people. And so bundler plugins have been available since 1.13, but only one hook was available, before install all. I went and added after install all, before install, and after install hooks for bundler 117. It's available at this pull request, and I think Colby's at the back. Please merge that. And I added some documentation as well because there was no documentation. And so you'll be able to use these a lot more easily in the coming weeks. So TLDR, unit tests aren't just for logic. Test your project, test your code by inputting your code as the input. Rubocop can help enforce tedious style guides and security, and they can automate and educate. Just-in-time education provides useful information and avoids cognitive overload. Remember the what is wrong, why it is wrong, and how to fix it. Those are 3 things that you should always have in your error messages. You can parse output to give good errors, following education principles, and you can use the bundler plugins to enforce rules on bundler. I'm sure this is available for other areas, and my plugin should be available publicly pretty soon. Like the repo is actually accessible, it's just not really finished. It works, but I can't guarantee it'll work well. And yeah, overview. People can't remember everything. I'm sure you don't remember half this presentation because of cognitive overload. We can automate unit tests and analyze the project for users and remember the tedious stuff for them, like reading this presentation again. You don't have to remember all the tedious stuff I just talked about. We can use these moments to educate people with information just in time. And I gave lots of examples, and I'll post the slides online with those examples in the following weeks. Arigato. Thank you.
Hey, thanks for the talk. I was just curious, the example you showed with RMagic, of course, is one that we've probably all run into, and it's very specific to RMagic. Do you think that all of these just-in-time education points would have to be very specific to the gem, or do you think there's any hope for like a generic error handling that would help more than just one gem?
Unfortunately, I think a lot of them are pretty specific, because it talks about the make. This is specifically the make file causing those issues. What's interesting about RMagic is it seems to be abandoned. Nobody's done anything for about 2 to 3 years. So I actually recommend people use MiniMagic instead, which is what we're switching to, which supports ImageMagick 7. And so yeah, I think we're going to have to just keep finding these errors and add them. So I'm trying to figure out a way to deploy, essentially, more error message handling without upgrading the gems all the time. Yeah, no problem.
I'm curious to what would you do if it was a microservice architecture? Because as we know, microservice can be different across the entire organization. So like in on the first microservice, you can have the rules to ban certain gems, but on the other microservice, you should not ban certain gems. How would you manage to do those rules of tests across different microservices?
Yeah, and so there's certain ways you can handle this. You can handle it by injecting tests if it's, like, for example, all Ruby using mini-test. And so this is where a consolidated environment does help. You could add a gem, potentially, that does the same thing across many things, or you can add specific style guides per project. I think it really depends on the projects and the implementations, to be honest. I would hope that microservices are as consolidated as possible, just so it makes it easier to maintain on an infrastructure perspective. Cool, thanks. I have about 1 minute left.
1 minute, all right, we'll go fast. Hi, I'm Paul from Stripe Developer Productivity. Good team name as yours. I have 2 questions, probably. First one, do you encourage your developers to install Rubocop in their editor?
No, we do not. I don't use it in the editor myself. We actually run it as a CI thing, and we run it. We have a thing called Policial, which will run only on the code that you change, and will help you autocorrect by pressing a button in a web UI. And it takes use of GitHub's checks API that was just released.
That does remove my second question. we have moved a lot of our tests into Rubocops so that their editor tells them that they're making a mistake rather than having to wait for CI.
We don't have a consolidated editor environment, so people use whatever they want. So that's the end, though. Thank you very much for coming, and have a good Kaigi.